Okay, here's the second example for section 3.1. And here we are going to look at our second method. We are going to look at solving quadratic equations by using square roots. So here you'll see what our method is. Write the equation in the form u squared equals d, where u is an algebraic expression, and solve by taking the square root of each side. So the reason why we're going to do this is because in quadratic equations, your variable has an exponent associated with it. And in order to isolate our variable, we have to get rid of that exponent or undo it. So what this means is we need to isolate the part of our function that is being squared and take the square root so that we can get our variable by itself. So let's go ahead and look at some problems right here. So let's start with A. All right, so here we've got a quadratic, 4x squared minus 31 equals 49. So we want to isolate the part that's being squared. So you'll notice right here that our variable x is the term that has the squared with it. So we need to move all of these terms around to get that squared part by itself. So first thing we want to do, let's go ahead and add 31 to both sides. 4x squared equals 80. Now, we haven't isolated our squared part yet. We still need to divide by 4. So let's divide by 4, and now we get x squared equals 20. Okay? Now, here we take the square root. So at this point, what we're doing right here is we're taking the square root of both sides. Now remember, when you take the square root of something squared, those cancel out. So you're left with just your variable. Now, this is something to remember back from Algebra 1 when you learned properties of square roots and taking the square root of a term. When we take the square root, when we're trying to find a solution to a variable and we take the square root of both sides, we always have to account for both the positive and negative solution. Okay, if we look at something like this, we're taking a side note for a second. If we're looking at x squared equals 9, okay, what we're really asking is what number times itself equals 9. If we took the square root, if we just said this, if we just said x equals 3, well, that's partially true because 3 times 3 does equal 9. But we're also forgetting the negative part. That's a negative 3. That's a comma negative 3. Because negative 3 times negative 3 equals 9 as well. So when you take the square root, you have to account for both the positive and negative case. Okay, so that's why we have this plus or minus. So here we get x equals plus or minus root 20. If you forget to put the plus or minus, you're missing half your solution, so that's not completely correct. Now, to simplify, again, this is going back to Algebra 1 when you learned how to simplify radicals. Okay, we factor out. We see that 20 is just 4 times 5, which is the square root of 4 times the square root of 5. Square root of 4 is 2, so we get x equals plus or minus 2 root 5. Okay, if you need help remembering how to simplify your radicals, come see me so we can talk about that, or you can go on to Khan Academy or any math website and get some extra practice. Okay, but again, this is something you learned in Algebra 1 that you need to remember how to use. Okay, so here, taking the square root of both sides, we get that our answer is x equals plus or minus 2 root 5. What that means is the solutions are positive 2 root 5 and negative 2 root 5. So here's an example where we have two solutions. Okay, let's go ahead and look at our next one right here. We'll go a little faster through these now that you saw the process. So in the second one, we need to simplify, or we need to isolate our squared portion. So what we want to do, let's go ahead and subtract 9 from both sides. So now we have 3x squared equals negative 9. Remember, we're only squaring the x right here. So we need to isolate x squared. So we need to divide by 3. You're not ready to take the square root of both sides just yet. You have to get the x by itself. Okay, so let's divide by 3. We get x squared equals -3. Now, this is an example of a problem that does not have a solution. Okay, if we tried to take the square root of both sides, okay, if we did square root of both sides, you cannot take the square root of a negative number. You should remember that from previous math classes. So because you can't take the square root of a negative number, this does not exist. This is a false statement. No number times itself will equal -3. So this is an example of an equation that has no real solution. Okay, so when you get something like this, you know that you can't go any further and there's no real solution. For our last one, let's go ahead and look at this one. So up to this point, all of the problems we've been looking at, our variable has been the term that we're squaring. Right? We've been isolating x squared because that's the part of our equation that we're squaring. Here, if you look at it, we are squaring everything in parentheses here. So that's what we need to go ahead and isolate. Now, I'm going to show you a common mistake people make on this, and hopefully you won't make it. So x plus 3 squared, this is what we're trying to isolate before we take the square root. So before we can do that, let's get rid of this 2/5. So we want to multiply both sides by 5/2. So we're going to get x plus 3 squared equals 25/2. Again, we're just multiplying by 5/2 on both sides. Now, right here, a common mistake is I see people try to subtract 3 from both sides and then get x squared by itself and take the square root. That is not correct. This plus 3, this is all one term, this x plus 3 in parentheses. And you cannot just subtract the 3 outside of those parentheses. You're skipping your orders of operation. This exponent has to be applied to this term before you could take the 3 out of there. So at this point, this is where you would take the square root of both sides because you've isolated your term that's being squared. So do not, when you have something like this where you've got some expression in parentheses that you're squaring, do not try to take your terms out of there. Please do not. So let's go ahead and take the square root of both sides. So the square root's going to cancel out the squared here, and we're going to get plus or minus the square root of 25/2. Okay? Now look what happened. We're left with x plus 3 because all we did, the square root gets rid of the exponent. Okay, now we still have to isolate x. So let's subtract 3 from both sides. So don't forget your plus or minus. And we know that we're going to have 2 answers to this problem. So here, our 2 solutions are going to be -3 plus root 25/2 and -3 minus root 25/2. Okay? And we can simplify this because we know that 25, we can take the square root of that and get 5/2. And here we're just rationalizing our denominator because we can't have a denominator in there. So we're multiplying both sides by root 2/2. Again, this was something you did in Algebra 1 to simplify your radicals. See me if you have any questions on it. So what we're going to get, this ends up simplifying down to square root of 25 is 5 times root 2 all over 2. Again, these last steps right here, these 2 right here, are simplifying your radical into an acceptable form. Okay, so here our final answers are -3 plus 5 root 2/2 and -3 minus 5 root 2/2. Okay, again, you can come back and watch any of these if you have questions on how to do them. What I want you guys to do are find the solutions for 4, 5, and 6 using square roots. if there aren't any solutions, type in that, or if there's one or two solutions, go ahead. Please label them clearly so I can see the answers to them. Go ahead and enter them in now.